My name is Prabhat Yatti. I am studying BSc second year. My combination is CBZ SSGFGC Nargon. Valence bond theory: strong and weak field complex of carbon, iron, carbon monoxide, nickel, copper with coordination number 4 and 6 and their magnetic properties limitation and valence bond theory. Valence bond theory. The suitable number of atomic orbital SPD of center metal atom hybridized to provide empty hybrid orbital. Hybrid orbitals accept lone pair electrons from the ligands and are directed towards the ligand's positions according to the geometry of the complex, such as octahedral, tetrahedral, superplanar, etc. When inner d orbitals Ni d orbitals are used in a hybrid, the complex is called inner orbital or lone spin or spin pair complex. When outer d orbitals Nd orbitals are used in a hybridization, the complex is called outer orbital higher spin and spin pair complex. If unpaired electrons are present within a complex, then complex is permanent in nature. Will it all the electrons are paired, then complex is diamagnetic in nature. A inner orbital complex CO CN6 3 minus ion. This complex the oxidation state of cobalt is +3. The valence shell electrons configuration of CO3 plus 3d6 strong and therefore causes the Cn minus ligands are paired of 3d electrons. All 6 3d electrons are therefore paired and occupy thereof the q3 orbitals. The valence 3d orbitals combine with the sent use and 4p orbitals to form 6d2 sp3 minus hybridized orbitals. That 6 hybridized orbitals overlap with 6 filled orbitals of ligands covalent bonds to form 6 carbonate. Outer orbital complex Fe F6 3 minus ion. In this complex, the oxidation state of ion Fe is +3. The valence shell electrons configuration of Fe3 is 3d5 and F ligands are weak and therefore causes no pairing of 3d electrons. All few 3d electrons are therefore occupy on few 3d orbitals. The Vasant 4s orbitals combine with the Vasant 4p and 2 Vasant 5d orbitals mixed with each other to form 6 sp3d2 hybrid orbitals. Their 6 hybrid orbitals overlap with 6 filled orbitals form ligands to form 6 covalent bonds. Hybridization dsp3 geometro planar diamagnetic number of unpaired electrons. Lone spin complex electrons in 3d orbital get paired. Cn minus is strong field ligand. NiCO4 tetracarbonic nickel is orbital of Ni384s2. Hybridization sp3 geometrotetrahedral diamagnetic number of unpaired electrons. Lone spin complex electrons in 3D orbitals get paired. CO strong field ligand. Limitation of valence bond theory. It could not explain the nature of ligands. It could not explain why the pairing of electrons occurs in the presence of strong ligands. It could not explain the color and electrons spect of complex. It could not explain reaction reacts and the mechanism of reaction of complexes. This theory does not provide any quantitative impressions data about the thermodynamic and kinetic suitable of coordination complexes.